Okay, the producer of this segment is telling me that people want to get right to the nub. But that's difficult. What we've undertaken here is a whole new theory of quantum. And you know, politically, scientifically, how do I want to put this? Within the context of what the physics community requires of physicists, this is not what you want to be doing. Maybe you want to do it quietly in your own room, but to actually publicize the fact that you're endeavoring to suggest that one of the central theorems of quantum mechanics might not be perfect. It's not something you want to undertake lightly. So we have to understand, or I have to explain first why it's important to embark on this voyage. And then to explain, and to do that, I have to explain what's wrong with the current set of theories called quantum mechanics. And I also have to explain what's superior about and different about the new theory of Randy Mills. Okay, I think I'm going to start by very briefly reminding everybody what the theory of Randy Mills is, the classical quantum mechanics. Essentially, he says the atom, all atoms, consist of a nucleus, and we don't have to concern ourselves with the nature of it. It's got plus charges, it's central, and around it electrons. But these electrons aren't little planetary bodies. The solar system is not a proper physical model of this version of the structure of an atom. In the classical quantum mechanics model of the atom, the proper model is a series of bubbles, like almost soap bubble-like objects that surround the nucleus and have physical motion within them. And we don't even get into the details of that motion. But basically the model says that you can apply Maxwell's equations and Newton's laws, nothing else, nothing new, to predict at what radii these bubbles will be stable. And all you have to do is set up a force balance based on Coulombic attraction for a one-electron system, for example. And say, okay, you also require that the electron have the h bar over 2 of angular momentum. Using those two requirements, you actually find that you have a particular solution that says this is the so-called ground state of the electron. And if you apply this very simple force balance, no new physics here at all, just a new geometry, you'll get the ground state of all one-electron atoms that are measured, starting with hydrogen, helium plus, etc. Okay, so that's the new theory. The new theory really isn't new. I mean, that's the misconception. On the other hand is what's now the current paradigm of quantum mechanics, which is the what we all call standard quantum mechanics. And what we're going to learn, first of all, is there really is no standard quantum mechanics. That's one of the big surprises. There's at least 3 families of theories of quantum mechanics, and they're all contradictory to each other. And once we see that there's actually 3 families, and why there are 3 families of theory, because to find agreement with experimental data, we need each of these theories. But we don't have the luxury of jumping back and forth between them according to what piece of experimental evidence we want to agree with. That's, according to Karl Popper, that's an inconsistent theory, therefore it's not a theory at all. So, all right, before I get back to more detailed descriptions of classical quantum mechanics, I want to talk briefly about the 3 families of standard quantum theory that exist today. The first one is the one...
I'm going to stop here.